Hello, this is Tolbert's class. This is actually the second lesson. It's basically a continuation of the first lesson, but in this one, you're going to be needing your periodic table, the one that you created in my class. It's just going to be drawing some things so that you can figure out where things are organized on your periodic table. We'll be organizing the periodic table. The metals, the nonmetals, and metalloids. Okay, the whole thing is the Group 13 through 18 are known as the nonmetals on your periodic table. And metalloids, they simply show a tendency to both metals and nonmetals, and they tend to be on the stair step. So this is where you're going to be starting to pull out your periodic table. So looking at these ones on the left and on the right, here are the nonmetals. And I'd like you to, I don't know, put a line around them or do something special so that you know those are nonmetals. And then I'm going to want you to draw this stair step. This stair step is the line between the nonmetals and the metals. They're called metalloids. Okay. And you've seen many periodic tables that have these lines, and now you know what they stand for. They are different types of these metals. Okay, now using your periodic table, you're going to draw what we call the oxidation numbers over the top. Okay, your periodic table starts over here with hydrogen, and I want you to put a +1 over hydrogen, +2 over beryllium, +3 over boron, plus or -4 over carbon, -3 nitrogen, -2 oxygen, -1 fluorine, and 0 for the noble gases. These numbers here represent what's going to happen with the oxidation with the outermost energy level of the valence electrons. Everybody here wants to give away one electron and end up being a +1 ion. These guys want to give away, this group wants to give away 2 electrons, end up being a +2. 3 electrons end up being a +3. These ones here, they're all going to want to gain electrons. And once they do gain electrons, they become negatively charged, gaining 3 electrons to 1, and they don't have to gain anything on that last one. Halogens tend to be toxic gases or liquids in their pure form. Fluorine, chlorine, and bromine, they're very, very reactive. And if you look at the list, those ones are very reactive because they want to take one electron. They'll do whatever it takes to take one electron, making them very, very reactive. All right, so that's the end of that second lesson there. Hopefully you drew those nuances into your on your word map, sorry, into your periodic table, because we're going to be using that in order to figure out how we're going to be